Hi again. So in this video, we're going to look at the relationship between the confidence level and the significance level. So since we were just comparing the hypothesis test and the confidence interval, those results, we might want to make sure that our confidence level and significance level match up, right, are analogous to each other. So let me show you what that means. And we're going to use the abbreviation C for the confidence level, and then we're already familiar with alpha for the significance level. Okay, so let's start with a two-tail test. It's a little more intuitive for a two-tail test because a confidence interval is also two-sided, okay? So for each of these, I'm going to draw a little normal curve. So I'm going to draw a horizontal line first. Then I'm going to come in with my haystack bell shape curve like that, okay? Doesn't have to be perfect. Just a little sketch is fine. Okay, so on our question here is if alpha equals 0.10, okay, so 10% significance level, find C, find the confidence level that would match with that or go with that. Okay, so if alpha is 0.10 and it's a two-tail test, okay, then let me draw my two tails. That means we would have 0.05 in each tail. Right, so when if we're doing a two-tail test with alpha, we're adding up both tails, okay? So that would mean we could have up to 5% in each tail, okay? So then to find, and this whole area adds up to 1, right? So 1 minus 0.10, because that's both of those, equals 90%, okay? So a 90% confidence interval matches up with a 10%. And I think a lot of you have kind of noticed this already, either in Stats 1 or in Stats 2, that if it's a two-tail test, then a 90% confidence interval is kind of like doing a test with 10% significance. Okay, so one is just looking at the tails and one is looking at the center. Okay, so I kind of used a formula for that where the confidence level is 1 minus alpha, or 1 minus 0.10, which is 0.90, right? So we get 90% confidence. Okay, let's do another one. Let's do if alpha is 0.05, find C. Okay, so I'm going to draw start with the same bell shape. Okay, and put my two tails in there. I could have made them a little smaller. Actually, that would have been better. But because this is 5%, then I'm going to have 2.5% on each side, 0.025. 0.05 divided by 2, I get 0.025. All we really need to know, though, is that the two tails add up, right, in a two-tail test. The two tails, we add them up. So if it's a 5% test, that's the maximum that p-value could be. So I'm going to do 1 minus, to find the middle, 1 minus 0.05 is 0.95. Okay, so C is, put C equals 0.95. So that would be a 95% confidence. Okay, now let's do one going the other way, and then we'll switch over to the one-tail test. Let me pick a new color here. Starting the same way, drawing the bell-shaped curve. And okay, I'll make it, I think it's going to be smaller even this time, because it says if C, so we're going to go the other way. If it's a 99% confidence interval, what alpha would that correspond to? So that would mean these two tails would have to add up to 1%, right? So alpha would be 1 minus 0.99, which is 0.01. So our alpha would be 0.01. Now we could cut that in half if you wanted to know each side, and actually that's kind of what we'll be doing for the one-tail test. So if you wanted to, that would be 0.005, right? Because it has to go smaller. Okay, so I bet from doing this you can kind of see the formulas, how they work. So alpha is 1 minus c, or c is 1 minus alpha. Okay, it's a really nice relationship when it's a two-tail test because the two-tail and the confidence interval is two-sided. Okay? Okay, now we're cutting some things in half, so you can see that's what we're going to be doing for the one-tail test. So let's go, let me pull this back down so we can go back to the one-tail test. Okay, so if alpha equals 0.05, find c, and now it's a one-tail. So let me draw my bell-shaped curve. Doesn't matter which side I draw it on. I'll just pick the right side. If alpha is 0.05, so now this whole thing on the right, the whole right tail is 0.05 instead of where I was cutting it in half before. Okay, so, but if we want this to be equivalent, a confidence interval is two-sided. So I need to think about what would be in the other tail. And that would be, to keep it symmetric, also 0.05. Okay, so then I can show you that our confidence level, to get in the middle, we need to subtract both of these. So we need to do 1 minus 2 times 0.05, or 1 minus 0.10, which is 0.90. Okay, so isn't that interesting? So if we have, these both have 90% confidence, so, but for a two-tail test, that corresponds to a 10% alpha. In a one-tail test, that corresponds to 5% alpha. Okay, so we want to be comparing apples to apples when we compare our hypothesis test with a confidence interval. So this is, again, 90% confidence, but our alpha was different. Our alpha was 0.05. Okay, let's try this again. If alpha is 0.025, find c. Okay. 0.025, so I'm going to make it a little smaller this time than it was before. I'll put it on the left this time. 0.025, let's say it's a left tail test. Okay, but we want to compare this confidence interval, and because it's two-sided, we need to also take into account the 0.025 that's in the other tail, and to find this middle area, right? Because the confidence interval always uses the middle percentage. Okay, so we want it to match up with this alpha over here, so it has to match up over there as well. So our confidence level C would be 1 minus 2 times 0.025, and you can kind of see from over here when we divided that, that divided 0.05 in half, we got 0.025. So this will be 1 minus 0.05, which is 0.95. So this is 95% confidence. Okay, so see how that works? Now I have some formulas at the bottom, but I find it easier just to draw a little picture each time. That's what I do. But I will show you the formulas too. So you can do it either way. Before that, let's do our third one. Let's go the opposite way. Okay, so if C is 99%, the same one over here, if C is 99%, find alpha. Okay, so this time we know we have 0.99 in the middle, but we have a one-tail test, so I don't know, I'll just draw it on the right. Okay, but we also have to consider that mirror image on the left. Okay, so that means there's 1% left, but we have to divide it among the two tails. Yeah, because this is, yeah, these have to add up to 1 and to make that 100. So we're going to do 1 minus 0.99 is 0.01. So I was kind of doing that part in my head. There's 1% left. Now we need to divide it in half. 0.01 divided by 2 is 0.005. Okay, so here I get 0.005. We also have 0.005 on the other side, just like over here with the two-tail test. The difference is, oh, I'm sorry, that was below my screen. The difference is here, so we have 1, let me just repeat that. 1 minus 0.99 is 0.01. Then we divided that by 2. 0.01 divided by 2 is 0.005. If it's a one-tail test, then our significance level is just the one side, so it's 0.005. Okay, so if you like formulas, then we have those for you. Alpha, and that's essentially what we just did. If we're finding alpha, which this one was finding alpha, so let me write alpha equals there. If we're finding alpha, we do the 1 minus the confidence level, and then we divide that by 2. Okay, and that's what we just did there. If we're finding the confidence level, then we took 2 times alpha and subtracted that from 1. So 1 minus 2 alpha, okay? Or you can always sketch it out. That's honestly what I do because it just feels easier to me, okay? Whichever way works best for you. Okay, great. I'll see you in the next video.